Okay, so let's get started. So like I said, this section, our first section in geometry, it's about points, lines, and planes. So everything that we learn about in geometry are made of points, lines, and planes. They're referred to as the building blocks of geometry because everything's made of them. So I have pretty much all the definitions typed in just to save time, and I'm just going to go through the examples of how to name them. So there's different ways to name all the different figures. So first one is a point. So you learned how to plot points in probably like pre-algebra or something like that in middle school. Ours aren't really on the coordinate plane, but it's still a location and it doesn't have a shape or a size. So that's what an example of a point would look like in a picture. It has the little point and then there's always a capital letter. And so if I asked you to name that point, you always name it with that capital letter. And what's important is that it's a capital print letter versus cursive letter. So you'll see that some things in geometry are named with cursive letters, which I don't think you guys learn cursive anymore, right? I don't know. But I will show you how to just make it like look a little fancy. So if we wanted to name this point, we would just write the word point and then a capital P. So always capital, super important when you're naming points. Okay, the next definition is a line. So again, you learned how to graph lines in Algebra 1, right? So our lines that we're going to learn about in geometry are not on the coordinate plane. They're just like, it's called in space. It's made of an infinite number of points. There's no thickness or width, and you need 2 points to make a line. Here's an example of what a line could look like. Sometimes the lines that we see will have like a lot more points on it. Sometimes it'll have no points on it. It just depends. Technically, it's made of an infinite number of points, but sometimes only a few of them are like marked on there. So there are 2 ways that we can properly name a line. The first way is we can choose any 2 points that are on the line. So see how I had A, B, and C on here. So you choose any 2 of them. It doesn't matter. The order doesn't matter either. So I could call this line AC or line BC or line CA or line CB. I could keep going, okay? So the order doesn't matter. And there's a symbol for a line if you're using 2 points. So say I was going to do AC, you would do capital A, capital C, and then the symbol for a line is just a miniature little line on top of the letters. So that's the case in geometry a lot. If there is a symbol for something, it's usually like a miniature version of it. So that's how you would show line AC, and it's important to put the arrows to show that it is a line and not something called a line segment, which we'll learn about a few rows down. So I'm going to put a couple. So we could do line AC, we could do line CB. There's a bunch more. You could write the word line if you prefer that. Like you could say line BA, let's say. I usually use the symbol, but whatever works. Okay, so that's the first way we can name a line is with any 2 points that are on the line. The second way is we can use, and this isn't always there, but sometimes it is. See this right here? That's supposed to be a lowercase l, a cursive lowercase l. So sometimes the line will just have a lowercase cursive letter like next to the line. That's not a point, that's just a label for that line. So if that's there, you can use that. So if I wanted to name it line L, I can name it line L. The thing is, I can't use the symbol if I'm using the cursive letter. So geometry has a lot of silly little like rules like that, which seem weird, but that's just the way it is. So if I'm going to use the cursive letter, you have to write the word line and then the cursive L. So if I did this, that would be incorrect. So you can't put the symbol above the cursive letter. You can only use the symbol with the capital letters. Okay, so those are the 2 ways we can name a line, with 2 points or with a cursive letter if it's there. Okay, the next definition is a plane. So a plane is a flat surface made of infinitely many points that extends in all directions. So like if you can imagine, like say like the top of like your desk, that could be a plane. So a flat surface. Obviously you can't show a flat, you can't show that it's going on forever, right? So how we usually show a plane is with a parallelogram like this, or you could do really any shape, like a triangle, technically could be a plane. So just it's supposed to be a flat surface. Planes can have points and lines and rays and segments inside of them. So this particular one has this line here, and it has a couple points that are off the line. So to name a plane, there are two ways that we can name a plane. The first way is we can name it with 3 points that are on the plane, but they cannot be on the same line. So see how A, B, and C are on the same line? I couldn't name this plane A, B, C, because those are on the same line. I have to choose 3. They're not on the same line. So I could call it like plane A, B, E. 2 of them could be on the same line. Or I could call it A, E, D. It's another way. So there's a lot of ways to name this plane with 3 letters, but you just can't choose A, B, C together. I do want to point out that this Y is not a point. See how it's like kind of fancier? That's supposed to be like a cursive Y. I'll get to that in a second. But in order for it to be a point, it has to have the little point with the capital letter. So what did I say first? Plane A, B, E. So that's one way you can name it. There isn't a symbol, although sometimes I've seen certain books use like a little miniature plane, but I usually just write the word plane. Maybe I'll put another one, plane EDC, I don't know. If you want to add to that, we could not say ABC. And again, we can't say ABC because A, B, and C are on the same line, so that's not allowed. Okay, so that's the first way you can name a plane with 3 points that are not on the same line. The second way is using this cursive Y. So if a plane has a capital script or cursive, whatever you want to call it, capital cursive letter in the corner, you can use that to name it. So I could call this plane Y. And you have to make it look kind of fancy. So you don't want to write this just like a regular Y. We don't want that. We need to make it look a little fancier. So put some little swirls. All right, so that's how we name a plane. Next up is a line segment. So a line segment is basically just a piece of a line. It does not go on forever. It has a definite beginning and end. Those are called endpoints. And a line segment could be measured. Like a line can't be measured because it goes on forever, right? But a segment could. So I can take out my ruler and measure this if I wanted to. So this picture here has 3 different line segments within it. To name the line segments, you use the endpoints, and it's in any order. It doesn't matter the order that you choose. And then the symbol for a segment is just like a miniature little segment above the letters. So I'm going to list all 3 of the segments in this picture. So there's this one from A to B. So that would just be segment AB. So capital A, capital B with the little bar on top. Now we're not putting arrows on top of this one because this is not a line. This is a line segment. I could also call that segment BA, AB, BA, doesn't matter the order. This one here would be BC or CB. And then the whole thing would be AC or CA. So from here to here. So that's a line segment. It's a piece of a line. Okay, next up is array. Array has one endpoint and goes on forever in only one direction. So if you look at this picture here, this is an example of array. See how it starts here at E and then it goes on forever through F in that direction. Technically, it could be part of a line too. Like I could extend this and this would still be array. It's array that's part of a line, but that's okay. So like it wouldn't include that part of it. It would start here and go that way. Sometimes this one only had 2 points on it, but just for the sake of when I name it in a minute, I'm going to add another letter on here, another point. You can have as many points. There's no limit on how many points you can have on something. So when you name array, so again, I want to name it from E this way. You choose 2 points that are on the array, but you must start with the end point. So the end point here is E. So I have to start with E. So since this has 2 points in the direction of the ray, I could call this ray EF, or since I added G there, I could call it ray EG. So either one, doesn't matter. If I had other points, then I'd have even more options. I could not call this ray GE. It has to start with E because this is the beginning of the ray. Okay, so we can call it EF. And then the symbol for a ray is a little miniature ray on top, and the symbol always points to the right no matter what. So even if like the ray is pointing to the left, your symbol always points to the right. So we can call it ray EF or ray EG since I added that G in there. So that's what a ray is. Okay, how are we doing so far? Does anyone have a question about anything, clarifying anything? Pretty good. Oh, thanks for the thumbs up. Very good. All right, so I'm going to go to the next page then, do a few more definitions, and then we're going to do some examples together. I'm going to have you guys help me through the examples, hopefully. Hopefully you'll answer me. One of my classes yesterday, no one would answer me, not even in the chat. It was painful. All right. Anyway, so next one up is opposite rays. So opposite rays are two rays. They have the same endpoint. They're on a line and they go in opposite directions. So they basically like make a line. So if you look at this picture here, this ray ST going that way, and this ray SR going that way, those are considered opposite rays. See how they make a straight line and they go in opposite directions, and they have S as the same endpoint. So they must share the same endpoint. Like you couldn't say that's a mistake that kids make is they'll say, oh, RT and TR are opposite rays because they go in opposite directions, don't they? And yes, they do, but they have to have the same endpoint. So it's basically like it starts at a point and they go in opposite directions. So to name the pair of opposite rays here, we would have ray ST and ray SR. Those would be opposite rays. Okay, next is collinear.
Excuse me?
Yeah.
So I have a question about opposite rays.
Absolutely. What is it?
So what S would be? That's the endpoint, did you say?
Yep. So wherever the ray begins, that's called the endpoint of the ray. Because this one here is starting at S and it's going to the right. And then this one is starting at S and it's going to the left. So S is called the endpoint of the ray.
Okay. And does the endpoint always have to be like directly in the center?
So not necessarily. Like, let me show you another example. Ready? So say I had this. So this would still be opposite rays, BC and BA. Even if I had other points here, I could like add in more points. And well, this now that I added all those points, now there's a lot of pairs of opposite rays here. I could have BC and BA. I could have DC and DA. I could have EA. And so any basically opposite rays, they have to share an endpoint and just go in opposite directions.
Okay.
I don't know if that helps or makes it more confusing for you because now I just added in all those points.
It does help.
It helps? Okay, good. Thank you for asking. All right, anyone else have anything right now before I go on? No? All right, collinear. Collinear, notice the word line in collinear. Collinear is points that are on the same line. So if you look at this picture here, notice that A, B, and C are on the same line. So those would be considered collinear points. When you list them, there's no symbol or anything for collinear, you just list them with a comma. So to fill in this blank, points A, B, and C are collinear. They're on the same line. And then non-collinear is they're not on the same line. So I could say D, E, and F are non-collinear. Whoops, I put E first. That's okay. E, D, and F. I could also say like A, B, and D are non-collinear. Even though A and B are on the same line, A, B, and D as a group, those would be non-collinear. So if you're listing collinear, they all have to be on the same line.
Would D, B, F be collinear?
D, B, F. Okay, that's a good question. It looks like we could maybe draw a line through them, but I don't know that it would be exact. So for the purposes of this, we would say that they're not collinear. So you don't want to start like drawing lines through all of them. So just go with like what the picture has.
All right.
Okay, good question. Okay, next is coplanar. Coplanar is points that are on the same plane. Just like collinear is points on the same line, coplanar points on the same plane. So if we take a look, I have two examples here. The top one is just a regular plane like I showed you on the front page. So A, B, C, and D, those are coplanar points. They're all on that same flat surface. And then I wanted to talk about, sometimes you have a 3D shape, like this is a rectangular prism, and rectangular prisms, or any prisms in general, are made of planes. Every flat surface, so every like face of the shape is considered to be a plane. So I could name some coplanar points rather on the rectangular prism. So just to show you real quick, I have, I'm going to switch to my regular camera for a second. So here is my rectangular prism. So what I mean is this is considered a plane, this is a plane, this is like every face is considered a plane. So if we're looking for coplanar points on a 3D figure like this, it would basically be like the corners. So like 1, 2, 3, 4, those would be considered coplanar. So anything on the same side, or like these 4. But if I picked like these 2 down here and like, I don't know, this one over here and this one down here, like those are not coplanar because they're not, you can't put a plane through all of them. One thing that is kind of hard to grasp is like these 2 up here. So these 2 and these 2 down here, I don't know if you can even like kind of tell. Those could be coplanar because you could put a plane through it diagonally. It's kind of hard to show, like not in person, but that might not even really come up. So I just wanted to mention, oh, my Chromebook's about to fall off. Hold on, let's see. Okay, there we go. So let me go back to this and we'll name some coplanar points on this picture. So see how like this top part of this rectangular prism has Q, X, Y, and R? Those would be coplanar. And then sometimes you're asked to count how many planes are in a figure. And so you would just count all the faces. So you have to picture, this is 3D, picture a box. You have the top and the bottom. That's 2. You have the front and the back. So that's 4. And then you have the left and right side. So that would be 6 planes. Now, sometimes you'll see a picture, which you'll see on the example in a second. Sometimes you have, they'll show like a box kind of thing, like a rectangular prism on another plane. And you're asked to count how many planes are in the figures. So I'm gonna demonstrate that. Let me flip back over to my Kleenex box. So let's say here's the plane that is on the bottom, piece of paper, and here's the rectangular prism. So when you're counting planes in a situation like this, the thing you have to be careful about is this bottom piece of paper plane in the bottom of the Kleenex box, they don't count as 2 separate planes. And that's because it's on it. So they're like merged together, if that makes sense. So if I'm counting planes here, I'm gonna have the top, the whole bottom, like the paper and the bottom of the box, that counts as 1 because they're like together, they're merged together. So it's gonna be top, bottom, so that's 1, 2, 3, 4, 5, 6. So this is still 6 planes, even though this plane seems like an additional one, but it's not because it's merged with the bottom part. So that's kind of a little tricky sometimes too. Go ahead, question?
Does the paper count as a plane?
The paper does not count as a separate plane because the box is on it. So they're like together as one, because anything that's on the bottom of the box is also on the paper. So that doesn't count separately. So in this situation, that would still be 6 planes.
All right.
Okay. Anyone else have a question before I move on? Okay, last couple last couple definitions. We have congruent segments. So the word congruent, which I sometimes say congruent, both are correct. I don't know why I interchange them. It's like whatever mood I'm in. So congruent segments are basically segments that are the same. We're going to see that word pop up a lot throughout geometry. We use it all the time. So anything that's congruent or congruent, it just means they're the same size and shape. So if I'm talking about a congruent segment, they have the same measure. And if you look at this picture, you see these little tick marks. Let me zoom in a little. This is a small picture. We mark congruent segments in a picture with the same number of tick marks. So see how EF and HG both have one tick mark? So that means that those two are the same length. So we would say that EF is congruent to HG. Same thing with AB and CD. Those both have two tick marks. So that means that those are congruent and they're the same length. And then there's something called a congruent statement where we're going to write it out with symbols. This is the symbol for congruent, is congruent to. It's an equal sign with like a little squiggle on the top. So if I wanted to write a statement saying that these two are congruent, it would be like this. Segment EF, so capital E, capital F with the bar on top, is congruent to segment HG, capital H, capital G with the bar on top. So that's called a congruent statement, just stating that those segments are congruent. I'm going to do one for AB and CD also. So AB is congruent to CD. Capital letters for my points, that's super important, and then bars on top. Okay, so that's congruent segments. And then the last definition is intersection. So all these points, lines, planes, rays, all the things we just learned about, they can intersect. And so if you think about like an intersection of two streets, right? It's like where they cross. It's the same idea with an intersection of figures. We want to see like where are they touching. Another way to think of it geometrically is what points do they have in common? So which points are in both figures? So there's different ways that figures can intersect. So first I have line L and line BI. So two lines will always intersect in a point. So see, line L is this one. Line BI is this one. So if you think about like where are those touching, do you see how they're touching at point B? So we would say that point B is the intersection of those two lines because that's where they touch. That's the only point that they have in common. So I'm going to write the word point with a capital B. Okay, next, a line and a plane. So there are two ways that a line and a plane can intersect. The first way is a little hard usually for kids to wrap their head around. So if I had a line, well, actually first, let me point something out. Do you guys see how BI has this like little dotted piece right here? So that dotted line, anytime you see a dotted line in a picture, it basically means that that part is behind the plane. So I'm just going to grab a piece of paper and show you what I mean. Let's switch back over to the regular camera. Okay, so say this is that plane R, and this is line BI. This is kind of like what that's supposed to be. It's going through it. So see right now, you can see the bottom of my pen. You can see the top of my pen, but see this like little in-between spot? You can't see that part of it. So that's why in a picture, they show that that part would be dotted. So this would represent that, I don't know if you guys see what I'm talking about. Like this part right here that I'm pointing to, you can't see that. So in a picture, they show that as dotted, like it exists, it's still there. It's just behind it. So it's a way for them to show you that that line is going through the plane. So that would represent line BI. Line L in that picture is on the plane, like this. It's lying flat, like inside of it. So when you're asked, like in this next example, line L intersects plane R. The pen is line L, the paper is plane R. Where are they touching? That's asked, that's like what an intersection is. What points do they have in common? Do you see how they're touching all along the line? Everything that's on this line is also in this plane. So this is the one that's a little weird for kids usually. We would say that line L intersects plane R at line L, which is like weird. Like how could it intersect it at itself? Well, because the whole line is in the plane. So everything on the line is also in the plane. So that's where they intersect. They touch at the line. So that one's a little bit weird. Usually the other one's a little bit easier to see, but you'll see once we do practice, it gets easier. So to fill in this one, line L intersects plane R at line L, because everything on line L is touching the plane. And that's what intersecting is asking, like, where are they touching? So then if I have line BI, where does line BI intersect plane R? Well, BI is like the pen shooting through the paper, right? It's only touching it where it's going through the plane. So that would be at point B here. Do you guys see that? How this line, it's going through, goes through the plane right here, and then it goes behind it and goes underneath. So it would be point B. So planes can intersect lines at a point or a whole line. It depends on how it's going through it. And then one other thing that I didn't put on here was two planes. So two planes intersect at a line. So if you want to add that in, if you're following along. Okay, so it's a lot, right? This first section has a ton of vocab. They're not all quite this many vocab words, but this one has a lot. So I'm gonna grab the attendance link. I'm gonna have you fill that out, and then we're gonna do that example. So once you fill out the attendance link, I want you to take a look. I'll project this. For those who do have it, you can just try these examples. We're gonna go through them quickly together before we break for some practice, okay? So hopefully you guys can see this. Once you do attendance, if you could just take a look at this and see if you can answer some of these questions. So I'm gonna grab. Okay, the first one, line FC. So line FC is right here. Intersects plane A at where? So if you want to put it in the chat, where does line FC touch the plane? Point B. Awesome. Nice job, guys. Just remember that it has to be a capital letter. So when you're writing it out, make sure you put a capital. Okay, great. Next, how many planes are shown in the figure? So this is like the example I did before. Keep in mind what I said about this bottom one and this bottom one. Okay, so remember, all right, a few of you have gotten it right so far. It's 6 planes. Remember that this is a 3D shape on top, right? So I don't know if maybe some of you said 1 because you just like saw the bottom. Every side of this rectangular prism is a plane, right? So the top, the bottom in plane A, remember, are merged together as one. So top, bottom, front, back, left, right. So it would be 6. That's a tricky one. So you just have to remember that the bottom of this box, I keep calling it a box. It's really a rectangular prism, but for the sake of the example, we'll call it a box. Remember that the bottom of the box in plane A, those are like merged together as one. So that just counts as 1. All right, how about the next one? Are points P, N, and M coplanar? So P is here, N is here, M is here. So picture those are all on the front of the box. So would that be considered coplanar? Yes. Awesome. Nice job, guys. So yes. Okay, how about this one? TQ intersects QP at where? So TQ is here. QP is here. Where do those two segments touch? Nice. A lot of people saying point Q. Awesome. So point, and then just remember capital Q. Oh, very good. All right. Name 3 points that are collinear. So there are 2 options here for 3 collinear points. What do we think? So 2 possible answers of a set of 3 points that are collinear. Remember, collinear means on the same line. Anyone know? So T, Q, and W are on the same plane, but they're not on the same line. See how like it turns here? So this isn't like one straight line. It would have to be like a straight line like this. W would have to be over here. Whoops, I don't know what the heck letter I just made. F, B, and C, good. So F, B, and C is one group of collinear. So we're not talking about coplanar this time, it's collinear. And then let's see, did anyone give the other three? There's another set of three. Awesome, Tyler and Kay, S, X, and M. So these three are awesome, are also collinear. So, or. Okay, great. Next, 3 points that are non-coplanar. So this one, I mean, there are so many answers. So a couple of you just want to put one in. Basically, as long as your 3 points are not on the same flat surface, they're considered non-coplanar. Someone want to give me at least one option? F, W, and T. Perfect. So F is over here, kind of like floating in space. W is here, T is here. So those 3 would be considered non-coplanar. Let's see a few more. T, N, C. T, N, C. Great. Yeah, T is up here, N's down here, C's down here. Definitely non-coplanar. M, Q, C. M, Q. Yep. M, Q, C. Just make sure that you're not saying that A is ever a point. A is not a point. A is a label for the plane. So yeah, as you can see, there's a bunch of options here for non-coplanar. Okay, number 7, name the line containing point B in 5 different ways. So here's the line containing point B. Remember to name the line, you can use any 2 points that are on the line in any order. And then remember the other way to name a line is if it has the cursive letter, but this one doesn't have that, so we can't use that. CB, okay, so line CB, so we could put capital C, capital B with the line on top. Anyone else? FC, great. FB, awesome. FC, yep, we got that one. What else? BC, great. I love that you guys are putting capital letters because that's super important. Make sure we're putting capital letters. What else? What other combinations have we not done? We could switch these 2 around, right? BF, CF, I think that's all of them. The more points that are on a line, the more options there are to name it. Okay, number 8 was 3 other ways to name plane A. So remember, to name a plane, you choose any 3 points that are on the plane. So they have to be on this bottom plane. So like these, B, R, N, S, X, M, but they just can't be on the same line. So basically we can't choose S, X, and M together. Anyone want to try? MRB, MRB, yeah, perfect, MRB works. Someone have another one? XNA, XN. Okay, so just be careful, whoever said that. A is not a point, remember? A is just, see how it's like a little fancier and there's no like point next to it? That's a label for the plane. So A wouldn't work, that's not a point. But SMN would work. And NSB, NSB would work too, great. And there are obviously like a bunch more combinations, as long as you don't choose M, X, and S together. All right, last one, name a pair of opposite rays. There is only 1 pair of opposite rays in this picture. Well, I guess technically there's 2, but you guys will probably just pick 1. Anyone want to try that one? Remember, opposite rays share an endpoint. Well, first of all, they're on a line. So there's 1 line in this picture, right? Oh, great, Bill, BF and BC. So CBF and BC. Awesome, BF. And remember, capital letters with the arrow, capital letters with the arrow. All right. Make sure though too, when you're doing your opposite rays, you have to start with the end point. So this is the only answer. You have to start with B for both of these. You can't do CB. Okay, so BF and BC, they come in pairs, so it's 2 rays. All right, so that's just about, I think I went a little bit over, sorry, but that's just about it for today. I'm going to show you